Let's look at this one right here, guys. This problem, there's a problem similar to this on your test. If you were to do this problem, how would you do it? Look at it for a couple of minutes. Well, why don't we plug in infinity first and see what would happen. If I plugged in infinity, you get e to the minus infinity times infinity squared, which is infinity, right? E to the minus infinity times infinity. If I got e to the minus infinity, guys, you need to understand that this is really 1 over e to the infinity. Are you guys okay with that? That's like the super number one thing that students don't understand. E to the negative infinity is 1 over e to the infinity, which means this is 1 over e to the infinity times infinity. And what is 1 over e to the infinity? When the bottom gets bigger and bigger and bigger and the top stays still, what happens in this fraction? It goes to 0. What do you do when you get 0 times infinity? Is the answer 0? No. This is an indeterminate form, okay? And we had a strategy that we talked about yesterday. If you have 0 times infinity or infinity times 0, you want to force it into a what? Do you remember? A fraction. Force it into a fraction and do L'Hopital. So let's start all over. Let's force this thing into a fraction. Fortunately, this one forces into a fraction pretty easily. They don't always, okay? So fortunately, this one forces into a fraction pretty easily, okay? And guys, anytime you get 0 times infinity or infinity times 0 and you force it into a fraction, something magical happens, okay? It always turns out to be either 0 over 0 or infinity over infinity, okay? It's just magic that way, okay? And so then you can do L'Hopital. So let's take a look at this. When you plug in infinity, do you see that you can do L'Hopital? Because you have infinity over infinity. Actually, we're not going to do it this way, but you could have actually even done this. You could have forced it into this fraction, okay? And this would have been 0 over 0, if you think about it, okay? And you could have done L'Hopital, all right? So this one's a little bit harder, so we won't do this way, but you could have done that also. All right, so what you have here is L'Hopital, so I'm going to go ahead and invoke the curse, okay? L'Hopital. What does the L stand for, though? Limit. So I'm going to copy this limit. L'Hopital is still a limit problem. I'll take the derivative of x squared, which is what, guys? 2x. I'll take the derivative of e to the x, which is what? E to the x. Okay. At this point, okay, I can do a couple of things. Why don't you guys tell me what you would want to do? What do you want to do? Would you like to plug in, or would you like to maybe solve right here? Okay, L'Hopital. So let's go ahead and plug in infinity. That would be infinity over infinity. Do you agree? So I'm going to do L'Hopital right here. What does the L stand for, guys? Limit. So this is going to be the limit as x goes to infinity. What's the derivative of 2x? 2. What's the derivative of e to the x? E to the x. If I plug in infinity right here, what do I get? As the bottom gets larger and larger and larger and larger, do you guys see that this is just really 2 over infinity, which is 0? Some of you guys might have seen it, but right here, you could have said that this one trumps this one. Do you remember that from long ago? As long as you have infinity, e to the x moves to infinity way faster than to the x. So this would be small over big, which is also 0. Anyway, you do it, you get the same answer. Okay? All right, any questions on this one? Again, guys, this unit is really abstract. So as we do this unit, you might be asking, hey, wait, wasn't there another way to do that? And possibly there was, or possibly there wasn't. You're just thinking incorrectly, okay? So make sure that you're doing the homework and you're actually asking questions on this unit. All right, this problem I want to just draw e to the x and e to the negative x and ln of x. And I want to just talk to you guys about the graphs of these things and the limits of these graphs, all right? All right, e to the x. Can you draw e to the x? You should be able to draw it fairly quickly. What's e to the x look like? You good? What does e to the negative x look like? What does e to the negative look like? Yeah, it's flipped on the y-axis, right? So this is e to the negative x. Okay, they both meet at this point here. What is this point here? You guys good with that? All right, so I'm going to ask you to answer some questions about this graph. What's the limit of e to the negative x? So now I'm looking at e to the negative x. So guys, that's the blue graph, okay? What's the limit of this blue graph as x approaches infinity? So as x gets bigger and bigger and bigger and bigger, What is this blue graph approach? 0. Okay. What about this one right here, guys? What is this? This is e to the negative x. E to the negative x, this blue graph here, as x approaches negative infinity. So as I get smaller and smaller and smaller and smaller, what does the y value of the blue graph approach? Infinity. Do you agree? Okay, so I want to talk to you guys about, hey, let's say we didn't know what the graph looked like. Okay, because a lot of times we don't draw e to the x every time we do this problem. If I plugged in infinity here, wouldn't that be e to the negative infinity right here? And what is e to the negative infinity? We talked about that. That's really 1 over e to the infinity. If you have e to the infinity, that's just infinity, right? That's just getting super large. And so when you get super large on the bottom and the top holds still, what is this really? 0. So do you see you can get 0 whether you know the graph or whether you just do it algebraically? Okay, same thing for this problem. On this problem here, if I plugged in negative infinity right here for this x, don't you see you get e to the negative infinity? And what is e to the negative infinity? E to the infinity, which is really just infinity. Okay, so do you guys see algebra makes sense? The graph should make sense. Okay, either way. All right, what if I plugged in 0 for right here? What should I get? 1. On the graph, do I get 1 when I'm at 0? Yes. Okay. Let's go to e to the x. So over here on e to the x, now I'm looking at the green graph. As x gets bigger and bigger and bigger, what does the y value of e to the x go? Infinity. Okay? And see if that makes sense. If I plugged in infinity here, would this go to infinity? Yes. All right. Let's look at the green graph. The next question is, as I go to negative infinity, as x gets smaller and smaller and smaller and smaller, what does this green graph? Oh no, am I going to green graph? Yeah. What does this green graph go to? 0. So I'm getting 0 here. Well, let's think about this. If I actually plugged in negative infinity here, e to the negative infinity, do I get 0? Yes. This is 1 over infinity, or 1 over e to the infinity, which is 1 over infinity, which is 0. Okay. What about if I plugged in 0 here? What do I get? 1. You're comfortable with that, right? Okay, just be careful. A lot of students think this is 0. Okay, so be careful. E to the 0 is not 0. All right, and then the big bad bear, okay, ln of x. How many of you guys missed this on your last test? This point right here. What was this point? 1, 0, okay? A lot of students said that this was 0. The x value was 0. The x value here is actually 1, okay? As x goes to infinity, what does ln of x go to? As I get bigger and bigger and bigger on the x side, what does the y value go to? Infinity, all right? So you guys need to know this, all right? What about as I approach 0 from the right? So here's my graph. As I approach 0 from the right, what is my y value going to? Negative infinity. Are you guys okay with that? Not super easy, but if you look at the graph and understand it, you can see that as I approach 0 from the right, y is going to negative infinity. All right, what about the limit as x goes to 1? 0. All you do is you plug 1 here. You can see when x is 1, that y is 0. Okay, what if I had this problem? The limit as x approached 0 from the left of ln of x. What if I'm approaching 0 from the left? It's d and e. Do you guys see it? There is no function over here. Does that make sense for ln of x from the left? So this would be d and e. All right. Okay, so another thing I need to talk to you guys about this is this right here. And so all these things, if you start getting confused in this unit, it's probably this slide that you need to go back to, okay? If I have a positive number, so I'm just going to say that's a positive number, and I divide by 0, and this is limit land, in limit land, what is this really? D and E. It's really undefined, right? It's D and E. Okay, what if I told you I have a positive number, and I divide by 0 coming from the right? Okay, so 0 coming from the right is something really, really small and positive, right? What would this be? It is D and E, but it's also something more specific than D and E. It's positive infinity, okay? What if I have a positive number on the top, it's positive, and I divide by 0 coming from the left? Now, coming from the left of 0, Okay, do you agree? It's a very, very small number, okay, but it's negative. So what's this going to be? Negative infinity, and you could also call it D&E. Now, why do I want you to know that it's infinity and positive infinity? Because sometimes when you're doing limits, you're going to get negative infinity minus infinity, okay? And that actually has an answer. It's determinate. It's negative infinity, okay? If you get infinity minus infinity, though, okay, then that actually is indeterminate, okay? Meaning you got to do something else. The method that you use actually didn't give you an answer, okay? So sometimes it's important to figure out, well, do you really have infinity or do you really have negative or positive? Does that make sense? If you just put D and E, you wouldn't have known, like if you had just put D and E, you would have said this answer is D and E, but it might not have been. There might have been an answer, okay? You just had to work it a different way, okay? So that's why I need you to know the infinity and negative infinity. All right. What if you have a number, and actually this doesn't matter. The number could be positive or negative, and infinity is on the bottom. What's this answer always going to be in limit land? 0. What if you have a number on the bottom? It doesn't matter if it's positive or negative. And you have a 0 on the top. What's this number going to be? 0. Okay? So guys, I'd like you guys, if you're having trouble with this unit, go back to this slide, post it online, and take a look at it and try to remember all of these different things that you have to remember. Okay, let's look at your homework from last night. What problems did you have? And I'll do 2 of them, and then I'll post my answers online because we don't have a lot of time today. So what 2 problems did you have to do? Actually, let's do 1 problem. I'll post my answers online. What problem would you like to do? 19. All right, here we go, guys. 19 on your homework. Okay, is the limit as x goes to 1 from the right, 3 ln of x minus 2 over x minus 1. Guys, if you're having trouble today, I'm here after school in 1661. Okay, so come by. Don't wait until you can't do any of the problems. All right. First, I'm going to plug in 1. Plug in 1 there. Plug in 1 there. So you see I get 3 over 0 minus 2 over 0. Okay. In limit land, a number over 0 is, well, this is this is 0. This is actually coming from the right. So I actually know this is 1 from the right. So this is actually 0 from the right. This is 1 from the right. So this is actually a positive 0. So I actually know that this is infinity minus infinity. Okay. And what is infinity minus infinity? Indeterminate. All right, guys, whenever you see 2 fractions like this, it's really, for limit problems, it's really just a common denominator. You'll have a problem like this on the test, okay? Just think of it like, remember when you did partial fractions, okay? Just get a common denominator, okay? On the top, this already has ln of x, so you want to multiply this by x minus 1. This one already has x minus 1, so you want to multiply this by ln of x, okay? This is the limit as x goes to 1 from the right. Okay, on the top here, if I plug in 1, this will be 0. If I plug in 1 here, this will be 0. So I get 0 minus 0. If I plug in 1 here and 1 here, I'll get 0 times 0. So do you see that this is 0 over 0? Okay, and you can only see that if you have 1 fraction. Okay, if you have 2 fractions, L'Hopital's doesn't work. L'Hopital's only works on 1 fraction. So I have 0 over 0, so what can I invoke? L'Hopital's. Okay, when I invoke L'Hopital's, what does this L stand for? The limit, okay? So what I'm going to do is take the derivative of the top. This is really 3x minus 3 minus 2 ln of x. So the derivative of 3x is 3. The derivative of 3 is 0. The derivative of negative 2 ln of x is negative 2 over x, right? Negative 2 times 1 over x. All right? On the bottom, guys, be very careful. The number one thing students do is just take the derivative of ln of x and take the derivative of x and multiply them together. Can you do derivatives like that? Can you just take the derivative of each one and multiply them together? No, what do you have to do? Product rule. So it's going to be the derivative of the first times the second plus the derivative of the second times the first. Okay? If I simplify the bottom, I'll get the limit here as x goes to 1. 3 minus 2 over x over, guys, what I want to do, and you'll have this on the test, make sure that you remember just to distribute here. That'll help you. This will give you 1 minus 1 over x plus ln of x. Okay? And I'm going to plug in the 1. If I plug in the 1, this will be 3 minus 2 over 1 minus 1 plus ln of 1. That gives me 1 over ln of 1, which gives me what? Is that 0? Yeah, it gives me 1 over 0. 1 over 0, which in limit land is undefined. Okay, Did I do that wrong? Okay, this is actually, to be technically, if I wanted to, I could say this is actually 1 from the right. Right? When I plugged in 1. 1 from the right. And so would this be ln of 1 from the right? Actually, it doesn't matter, right? ln of 1. ln of 1 is just 0 no matter what. So it's just the end. Okay? What was the answer to this? Did I check right? Yes. Okay. All right. Let's go ahead and move on. I know you might have other questions. Again, I'm here after school today, and then also I'll post the answers online. You can take a look at that. I'll post my work online too, so that hopefully help you. Okay, today what I want to talk about is improper integrals. You have your guided notes, so take a look at that. I'm going to move through it with you guys. The truth is, up to this point, every integral we gave you was an integral of something that was closed. It was a closed area. Okay, it was a continuous function. It was a closed area. Okay. Today what we're going to do is we're going to have these open area integrals. So let me show you what that means. The integral is really the area under the curve, right? So let me just go ahead and draw this curve. This is 1 over x. Do you remember what 1 over x looks like? Right? And if I want the integral from 1 to infinity, what I'm saying is get the area under this curve from 1 to infinity. So until it goes to infinity. Okay? And intuitively, what is this? Intuitively, what do you think this area under the curve is? Infinity, right? It looks like it's infinity, okay? But I'm going to submit to you that it's not always infinity. Sometimes it is infinity, and sometimes it actually converges to an answer. Okay, so let's look at this problem. The way you do these problems is because of this infinity, this is an improper integral, okay? Basically because if you look at the picture, it leaks out right here. So what you have to do is change this to a proper integral, and it really is a limit. So you change this as a limit, and you pick any letter you want. I'm going to pick b, but you can pick any letter you want. And you change it from the limit as b goes to infinity, and you replace the infinity with the letter b. So 1 over x dx. So you make it into a limit problem. Okay, and this is why L'Hopital's is so important for this today. Because we're going to do a lot of limits here. Okay, then this is what's called a proper integral. This is called an improper integral. So on your test, I'm going to ask you to show me the proper integral first before you solve. Okay, so this is the proper integral. Okay, you'll get points if you have this. You'll deduct points if you don't have this. Even if you get the answer right, I'm going to take off points because very likely your professor will take off points when you go to college. Okay, all right. Right here, what you do is you solve for the integral first, and don't worry about the limit. So the limit, you just carry him down. Okay. On this side, don't worry about even the b and the 1 here. What's the integral of 1 over x? ln of x. Okay. So that answer is ln of x from 1 to b. Okay. Then what you do is you still solve for this right side first. So I'm going to do the first fundamental theorem here. I'm going to get rid of this win bar. Okay. So this is going to be just carry down the limit. I haven't taken care of the limit yet. Okay. First, I'm going to plug in the b. Then I'm going to plug in the 1. Then I'm going to slap a minus sign between. Okay. So then you do the first fundamental theorem of calculus. Okay. And then you can simplify whatever looks good to simplify. Like this is really 0. Right. You can simplify it if you want. Okay. Then what you do is once you've taken care of this win bar, you can come here. You can say, all right, now I'll take care of the limit. Then everywhere there's a b, okay, make sure it's not an x now. Everywhere there's a b, you're going to plug in an infinity. So this is ln of infinity. And guys, what is ln of infinity? Think about the ln graph. What is ln of infinity? If this is ln of x, as x gets bigger and bigger and bigger, what does your y value go to? Infinity. So this answer is infinity. If it's infinity, we say that this answer diverges. Okay, if the answer is d and e or infinity, we say that the integral diverges. Okay, and that's exactly what we thought would happen, which is kind of cool. Okay, but again, I'm warning you that it doesn't always happen like that. We thought it should be infinity, and the area is infinity. But let's look at your second problem here. Okay, Let's graph e to the negative x. If I graph e to the negative x, okay, remember what that looks like. We just talked about it. It looks like that. Okay, I want the area under the curve of e to the negative x from 1 to infinity. So this area right here looks a lot like this picture, right? So if you had to guess what this area is, what would you say it is? Infinity, but it's not. So let me show you why. Okay, let's go ahead and take the limit, change this to a proper integral. So this would be the limit as b goes to infinity of 1 to b e to the negative x dx. And when you look at my notes, you'll see that I use different letters. I didn't always use b. Okay, then what I'm going to do is just solve this integral like I always do and just do the right side. This limit, okay, he's like a little brother, okay, an annoying little brother. I just carry him down. He follows me around, okay, and I take care of him at the end. Okay, oh boy, do I take care of him. But I'm not going to take care of him right away. He's just going to follow me around, okay? All right, what's the integral of e to the negative x? Negative e to the negative x, okay? Remember, the integral of e to the u with using pattern recognition is e to the u divided by u prime. E to the u divided by the derivative of your exponent. So this is going to be e to the negative x divided by the derivative of negative x, which is negative 1, but that's really just the same as negative up here. Okay? All right, so negative e to the negative x, and put your win bar in from 1 to b. Okay? The next thing you're going to do is do the first fundamental theorem of calculus. You're going to take care of that win bar. Okay? So again, carry down this little brother, the limit as b goes to infinity. Okay? Plug in your b, plug in your 1. Okay, get all your negative signs right. All we're doing is plugging in and slap a minus sign in the middle. Okay, you with me so far? And these negatives get pretty hairy. All right. Do you see the negative is a positive? You good with that? Actually, this e to the negative 1, do you see it's really just 1 over e? You guys okay with that? So I'm going to change this to 1 over e. You may or may not like that, but it's 1 over e. Okay, I'm done with the win bar. Okay, I can simplify whatever I want. At this point, I'm going to plug in the infinity. Okay. When you plug in the infinity, do you see you get negative e to the negative infinity plus 1 over e? Okay, as soon as I plug in the infinity, I can drop the limit. Okay, so I plug in the infinity, and what do you get? What do you get when you plug in infinity? Isn't this really negative 1 over e to the infinity plus 1 over e? Guys, you need to be able to move from here, e to negative infinity, to 1 over e to the infinity. That's got to be smooth for you. Okay, what is 1 over e to the infinity, though, really? It's really 0. So this answer is going to be 1 over e, which is interesting, because what that says is the area under this curve is not infinity. The area under this curve is 1 over e, and we say that that converges. Okay, we say the integral converges to 1 over e. Okay, kind of a weird thing. You can argue with me as much as you want that the area is infinity, but it's not. Okay, it actually converges to 1 over e. And it converges because the integral converges. Okay, if you actually graphed on your calculator 1 over x and e to the x, what you'll see is that the area under the curve for e to the x is way smaller. Does that make sense? Than the area under 1 over x. And that's part of the reason why this one converges and this one doesn't. But that's only part of the reason. The other part of the reason is just it just does converge. Okay? All right, let's look at this problem. Okay, it's always nice if we can draw a picture and see what's going on, especially when we come to tomorrow. Okay, right here, what you have is e to the x. You know what e to the x over 4 looks like. It looks a lot like e to the x, so you just kind of sketch it. And we want the area under the curve from negative infinity to 0. So here's your 0. So we're getting this area under the curve here. You can also see that this area goes on forever, right? Okay, there's a little bit of leakage there. Okay, and so that's the area we're trying to find. This is a problem child right here. So we're going to make that into the limit. So this is a limit as b approaches negative infinity this time from b to 0, e to the x over 4 dx. All right. I've changed it from an improper integral now to a proper integral. Okay, that's a step that you have to take whether you want to or not. Okay, this needs to be correct. All right, what you do is you solve this right side, carry down the limit like a little brother. After you take care of the wind bar and you simplify the problem, then you can take care of little brother, okay? Then you can take care of the limit. All right, what's the integral of e to the u? What is it, guys? It's e to the u divided by the derivative of your u. What's the derivative of x over 4? 1/4. So what's e to the x over 4 divided by 1/4? 4e to the x over 4. Put your wind bar in from b to 0. Okay? Carry down the limit. The limit as b goes to negative infinity. All right, what's your next step? Yeah, plug in the wind bar. Okay? Plug in the 0, plug in the b, slap a minus sign in between. So go ahead and do it. Plug in the 0, plug in the b, and slap a minus sign in between. Okay. Anywhere you can simplify, it would probably help you for the limit. But if you don't want to simplify, you can do it at the end. Do you see that e to the 0 is really what? 1. So you guys okay if I just make this a 4? Right? It's 4 times 1, basically. All right. Over here, I still have 4e to the b, 4. You guys ready to take care of little brother? Okay, we've done the wind bar, so let's go ahead and put in, everywhere there's a b, let's put in negative infinity. So this is 4 minus 4, e to the negative infinity over 4. But negative infinity over 4, you guys okay, is really just negative infinity. Okay? And again, you guys need to understand that e to the negative anything, okay, e to the negative anything is really 4 over e to that anything. Okay? So this is really 4 minus 4 over e to the infinity. But guys, what's this going to go to? 0. So your answer is 4, which is kind of interesting. What that says is that this integral converges. We say it converges to 4. Okay? And we expect it to be infinity, but it's not. It actually converges to an answer. All right, let's look at your next problem. For your next problem, you're going to have to remember the graph of arctangent. Remember the arctangent looks like this. It goes through 0, 0, 0, and also it has two asymptotes, one at pi over 2 on the right side, and one at negative pi over 2 on the left side. All right, so knowing that, go ahead and draw your picture, please, for this problem, and I've drawn it up here. Depending on which test you get, you may or may not have a problem similar to this and have to be able to draw it. Okay, and so it depends on if you're absent, you get a different test, or if you do a retake, you might have a different test. Okay, so you need to be able to draw this sort of function. And what I would do is I would just plug it into a t-chart and graph it. Okay. All right, so this is what this looks like. What you have to understand is that no matter what I plug in here, this number will always be positive. You guys see that? So this number will always be positive. So there's always going to be the area under this curve between the function and the x-axis. This area is always going to be leaking on both sides. You see the leakage on both sides. Okay. This is the function. It says R is a region between the graph and the x-axis. All right. So the area under the curve is going to be negative infinity to infinity of 1 over x squared plus 1. You guys good with that? The problem with this problem is that it's got two problems. Does that make sense? It's got this problem child and this problem child. And you can only take one limit at a time. Like, we've never done, like, take two limits at a time. It's impossible. Okay? So what you have to do is divide this into two problems. You see how to divide it? We'll just divide it into this area on the left and this area on the right. Okay? So this will be negative infinity to 0 of 1 over x squared plus 1 dx plus 0 to infinity of 1 over x squared plus 1 dx. Any suggestions on this problem? I'm thinking like maybe I could, just do it once and multiply by 2, right? So which one would you like to do once and multiply by 2?
The right one.
Yeah.
The right one.
Okay, let's do the right one, okay? But if you want to do the left one, you could do it in a closet, and I actually did it, and I'll put it on my slides, and you could check it, okay? All right, let's do the right one, then we're going to multiply by 2, okay? So we're going to do the integral of 0 to infinity from 1 over x squared plus 1 dx, and we're going to multiply that by 2, all right? And this is going to be the area under the curve. Well, let's make the improper integral a proper integral first. So this will be 2 times the limit as b goes to infinity from 0 to b of 1 over x squared plus 1 dx. Again, guys, this is a necessary step. Whether you think it's necessary or not, I'm going to grade this as some points. Okay, so you have to have this, no matter if you have the right answer or not. Okay, what is the integral of 1 over x squared plus 1? It is an arctan. Why is it not an ln? Well, because if this is my u, the derivative of x squared plus 1 is 2x, right? Do my x's cancel out? No. So not an ln problem, okay? It is an arctan problem, okay? My u squared is actually equal to x squared, so u is actually equal to x. My a squared is 1 squared, or 1, okay? So a is actually 1. The derivative of u is actually 1, so dx is actually du. When I do my substitution, I'll have the integral of 1 over u squared plus 1 du. And I look on my pink sheet, and the answer to this is 1 over a arctangent u over a plus Charlie. My a in my problem here is 1. My u in my problem here is x, right? So this is going to be arctangent x from 0 to b. I did that fast, but hopefully you knew that that was an arctangent problem. And lucky for you, you've already tested over that, so you already knew that. All right, don't forget the little brother, the limit as b goes to infinity, that carries down, and don't forget to multiply by 2 when we're done. What are you going to do next? Take care of the wind bar, right? Plug in the b, plug in the 0, slap a minus sign between, okay? We still haven't taken care of the limit, and we still haven't taken care of the number 2. All right? Once we take care of the wind bar, you can simplify whatever you want to simplify, you can. Do we know what arctan of 0 is? You know what arctan of 0? On that arctan graph, remember that arctan graph? When x is 0, what's your y? 0. So this is actually just 0. Okay? Let's go ahead and plug in b is infinity. So this answer is going to be 2 times the arctangent of infinity. What is the arctangent of infinity? What does the y value go to when x goes to infinity? Pi over 2. So what is your answer? Pi. Very nice. Okay? So the area under this curve is actually pi. That is so cool. All right. Let's move to your next problem here. You will have volume and area on your test, okay? So we need to not forget that, okay? If you graph e to the negative 2x, you have to know how to do that too. It's the opposite of e to the x, so it's going to look something like this, okay? You want to just look from 0 to infinity, so I'm just focusing on this part of this graph, from 0 to infinity. R is going to be the region in the first quadrant between this function and the x-axis, so this is my R right here, okay? You can see that R is going to leak out over here. Find the volume of the solid generated when R is rotated about the x-axis. So we're going to rotate this region about the x-axis. You can kind of see it looks like a sideways cone, okay, with some curved sides. And what we want to do is we want to get the volume of this. So V equals pi R squared. Is it a dx or dy problem? Dx, because you're rotating about a horizontal axis, okay? And if you didn't know that, you don't have to. You could say, well, I'm going to go, R is from the axis of rotation through the region to the furthest point on the graph, and you can see that R is a vertical Riemann sum, so you have a dx width, okay? So it is a dx problem, okay? Do I have a little r? Do I have a hollow part that I need to subtract out? No, okay? This region here is flush up against the axis, which is nice, so this is my formula. This is my r, so let me pull out r. Let me pull out r and ask you, what is the length of r? Is it y minus y, or is it x minus x? Y minus y. What's the top y? What's the top y of this r? E to the negative 2x. What's the bottom y? 0. Okay, so this r is going to be equal to e to the negative 2x minus 0. Okay, I'm going to plug that right into this formula. So v equals pi e to the negative 2x squared dx. What are my limits on this problem? What's my smallest x value? 0. What's my biggest x value? Infinity. So this is going to go from 0 to infinity. Okay? So let me rewrite my problem to make it proper. My problem is going to be the limit as b goes to infinity of pi times 0 to b e to the negative 4x dx. You guys get a power to a power, you just multiply. Okay, you with me so far? This is nice. I've got the proper integral. And once you have the proper integral, all you do is you just integrate it first. What's the integral of e to the u? What's the integral of e to the negative 4x? E to the negative 4x divided by what? Negative 4. Okay? And this will go from 0 to b. Don't forget to multiply by my pi. Are you guys okay if I pull the pi on the outside? Okay? So this will be pi times the limit as b goes to infinity. Okay? You can pull scalars out of limits. You can pull scalars out of derivatives and integrals. Okay? All right? Now what I'm going to do is I'm going to plug in the b. So this will be e to the negative 4b over negative 4. I'm going to plug in the 0. That's going to be e to the 0, negative 0, but that's just 0, over negative 4. I'm going to slap a minus sign in between, and I'm going to multiply all of this. Oh, no, wait, did I take the limit yet? I'm going to take the limit as b goes to infinity, and I'll multiply all by pi. Okay, let's take the limit of this thing. Guys, first of all, let's simplify. The infinity is only going to be plugged in where there's a b. There's no b in this term. Do you see that this is really just 1 over negative 4? Okay, and do you see that this is a negative negative? So this is just a positive. Okay? All right, I'm going to plug in infinity right here. Okay? So this is going to be e to the negative 4 times infinity. Isn't that just negative infinity? Negative infinity over negative 4, okay, plus 1 over 4, and all of that will be times pi. Guys, at this point, you need to be comfortable that e to the negative infinity can move to the bottom. So this is really 1 over, really negative 1 over 4 e to the infinity plus 1/4. All of that times pi. Guys, what is this term going to go to? 0, because this is going to get bigger and bigger and bigger on the bottom. So what's your answer? Pi over 4. Very nice. All right, let's go to the last problem. The last problem, I'm just going to tell you guys that this is a like bit problem. Maybe you saw it, maybe you didn't, but you need to remember all of your special integration. Okay. And so what we're going to do is let's first rewrite this problem. I see the problem child right there. So let me just rewrite it. B to the infinity, 1 to b, 1 minus x, e to the negative x dx. Okay. This problem is very special for several reasons. Okay. This is, you could distribute this and do a buy one, get one free, but I'm just going to tell you, you can actually act like this is a polynomial itself right here and make this your e, so it's a PE problem. Okay, you may not have done it. I did it the other way in the notes. This way is a little bit faster. So I'm going to go with this way, but if you want to distribute your e to the negative x, you can do that also. Okay, I'm going to do a table trick. Are you guys okay with a table trick on a PE problem? Okay, what's the derivative of 1 minus x? What's the derivative of negative 1? 0. What's the integral, antiderivative e to negative x? E to the negative x divided by negative 1, right? And the x's cancel out. That's great. And then if I take the integral again, I get e to the negative x divided by negative, so that's going to be 1. All right? This will be plus, minus, plus, slash, slash. So my answer is going to be negative 1 minus x, e to the negative x, plus e to the negative x from 1 to b. This will be the limit as b goes to infinity. Okay, just warning you, this is going to be a big mess. Okay, everybody good with me so far? Let me know if you see any mistakes. What are you going to do first? Yeah, take care of the win bar. Plug in the b, plug in the 1, everywhere there's an x, okay? And then slap a minus sign between. So this will be negative 1 minus b, e to the negative b, plus e to the negative b. Now plug in my 1, I get negative 1 minus 1, 1 minus 1, e to the negative 1, plus e to the negative 1. Then you slap a minus sign between. Make sure you understand this minus is minus this whole quantity. It's not just these turning positive. It's minus this whole quantity. Okay? I really like this 1 minus 1 because actually that's the only thing that's not confusing me in this problem. So I'm going to change that to 0. Everybody good with that? That 1 minus 1 is 0. This e to negative 1, what is that really? 1 over e. So do you see this right side is really just minus 1 over e? The right side wasn't too bad. The left side's pretty bad. Okay, so let's look at the left side. This right here, there's probably different ways to do this. What do you guys want to do? You want to distribute? I don't know what to do here. What do you guys want to do? Okay, let's distribute. That would be negative e to the negative b plus be to the negative b plus e to the negative b. The limit as b goes to infinity. Is good with that? Okay, now I'm going to plug in infinity. You guys good? So that would be negative e to the negative infinity plus be to the negative infinity plus e to the negative infinity minus 1 over e. What do I get here? This right here, remember what we said, how do we rewrite e to the negative infinity? 1 over infinity, right? So that's 1 over e to the infinity plus, this would be be to negative infinity. Oh wait, isn't this an infinity over here though? This is an infinity. Okay, plus e to the negative infinity. So this is actually 1 over e to the infinity minus 1 over e. Okay, some good things happen here and some bad things happen here, okay? This is 0 and this is 0. You guys good with that? This is infinity. Oops, this is actually e to the infinity. This is infinity over infinity. Do you see that? Or actually another way you could see it, maybe we should just leave it. If this were b, maybe we should, I wonder if we left this as b, so this is e to the negative b. Isn't this really b over e to the b, right? B over e to the b, right? And if we left it like that, it's actually a little bit nicer because this is the limit as b goes to infinity. Can you see what that is? Yeah, do you see it small over big? Because if you don't see it small over big, we're going to have to do L'Hopital's. We could do L'Hopital's. But do you see that small over big? Are you okay that this one trumps this one? Okay, so this one's going to go to 0. So what's your answer? Negative 1 over e. Okay, and that's the answer to this problem, which was so terrible. Okay, but it's a lighter problem. Okay, take a look at your homework, guys. So the very, very last problem, just to make sure you understand, is going to be a partial fractions. That's nice. Trying to help you guys out here. We'll do 8 together. Let's do 8 together. I don't know how much time you guys have here. Does anybody know what time we get out? Okay, at least we can start it. Okay, let's look at 8 together. 0 to infinity, that's x squared e to the negative x dx. Okay. Let's take care of the problem child. This is going to be the limit as b goes to infinity of 0 to b x squared e to the negative x dx. Okay. How do I solve this integral? P, E, table trick. So x squared on the left, e to the negative x on the right. Take the derivative on the left till you get to 0. On the right, take the integral e to the negative x divided by negative 1. The negative 1 does, the x's do cancel out. Then you divide by negative 1. Then you divide by negative 1 again. Okay. Then it's plus, minus, slash, slash, slash. So this answer is a limit as b goes to infinity of x squared e to the negative x plus 2x e to the negative x minus 2e to the negative x. I'm so lost. What am I doing? Okay. Oh, this is negative x squared. Thank you. Negative x squared, yeah, because this was a negative here. All right, x squared e to the negative x minus. No. Minus 2x, thank you. E to the negative x. Okay, now we're good, right? And we're going to take that from the win bar, 0 to b. We've already integrated it. Take it on the win bar from 0 to b. Okay, have a lot of room on your paper, guys. Start from the very, very left. Okay, copy this limit. The limit goes to infinity still. Okay, we're going to take care of the wind bar. So first we're going to plug in the b. So this is negative b squared e to the negative b minus 2b e to the negative b minus 2e to the negative b. Okay, plugging in the 0 is not too bad though. If you plug in the 0, do you see it's 0 minus 2e to the 0. Okay, the first terms just conk out. Don't forget to slap a minus sign in between. It's minus this entire quantity though. Okay, is everybody good? This right here is just going to be plus 2 because e to the 0 is just 1, right? So that would just be plus 2 on the right. On this side, it's a little bit more tricky, okay? So what I'm going to do is I'm going to move this e to the b on the bottom because I think it's going to make it a little bit easier. This will be negative b squared over e to the b minus 2b over e to the b minus 2 over e to the b. I think this will make things a lot easier. Plus 2. Okay. And this will be the limit as b goes to infinity. Okay? Guys, what happens at this as b goes to infinity? 0, because that's a Trump rule. You guys see the Trump rule? Okay. You thought the Trump rule was building the wall, but it's not. Okay. Over here, what's this going to be? Do you see that this is also 0? Okay, because e to the infinity is going to trump just x. Okay, so this is also 0. This right here is also 0. And so, guys, what's your answer? 2. Do you see how abstract this is? You guys see how, I mean, it's pretty scary how abstract it is. And so the more you practice, the better you get at it.